Any questions? Experiment 10 Prelab. Hold on. Let me go to the course. Okay. So if you look in the home page folder for experiment 10, Prelab is not there. Do you see the folder and you don't see the attachment, or you don't see the folder at all? Okay, if you see the folder, then it's different. Okay. KBR plus I2. Then it would be BR2 plus KI. Say? BR2 plus KI. Would that make sense? So the oxidation state for Br2 is 0. For iodide here is -1 or 1 minus. Then for KBr, oxidation number for Br is a +1. I'm sorry, -1. And in the I2 is 0. And wow, we have problems here. Let's see. I have to check my (1045) pre and post lab. And it's part B, right? Part B, Prelab. Okay, I have the Prelab for part B. Let me go to wow, I have to start grading. I have to start grading because I didn't grade anything. Okay. attach the file here, upload. Okay, so if you can please refresh the assignment folder, see if you can see the attachment. So at least I answer one questions of yours first. Bianca, the spectator ion in that reaction is going to be potassium only. Potassium is the spectator ion. So start with the Br minus and then plus B, what was it? So you start from Bi minus, Br minus plus I2. That yields Br2 plus Ki. That would be the net ionic because the Br2, it doesn't generate ions, so you don't change the ions, and I2 the same thing. I2 you don't break down to ions because those are molecular compounds. Did I answer that question? Okay. Perfect. Okay, any other question or concerns before we move to experiment? We're doing experiment 9 today, right? And I want to see if I can finally use the surface. Yes, yes. See if I can use. Okay, we go to the lab manual. Chemistry of copper. This experiment, you have to pay attention to the type of reactions that is happening in every step. The purpose for this experiment, there are two purposes for the experiment. One is the study of the law for conservation of mass. Ideally, if you start with 0.5 grams of copper and you cycle the copper through a series of reactions, you should end up with the same amount of copper. And that is, as I said, ideally. Second purpose for this reaction, for this experiment, is to learn about different type of reactions. So you could have precipitation reactions or double displacement reactions. You could have combination, decomposition reactions, acid-base or neutralization reaction. And in every step, you want to identify the reaction as what type of reaction is that. So in acid-base reaction, acid will neutralize the base or base would neutralize the acid. We could have a strong acid or weak acid. You could have a strong base or weak base. We have talked about this when we talked about electrolytes. So whenever you have acid plus base, the product is going to be salt plus water. In a redox reaction, which you had in experiment 8, in oxidation reduction reaction, one element will be oxidized, means losing electron, or oxidation number would increase. Like in this case, magnesium is going to go to, oh, there is a typo here. This magnesium is not a magnesium 2, it's a magnesium with 2+ charge. I just noticed this. So please pay attention to that. It's not a subscript, it's a superscript. Supposed to be Mg2+. Then you have combination reactions. In this combination reaction, when anything combines with oxygen, oxidation number would go up. So it's also considered as oxidation reduction reaction. Single displacement reaction is oxidation reduction type reaction as well. In decomposition reaction, there's a decomposition reaction here, and you have to calculate sometimes the oxidation number changes, other times it doesn't change. So you have to calculate oxidation number separately from the reactant to product, compare it to see if it changed or not. The cycle that I was talking about, you cycle the copper through sets of reactions. You start with copper, you add nitric acid first, and step 1 is going to change to copper nitrate, because nitric acid is strong enough to dissolve, concentrated nitric acid is strong enough to dissolve copper. So you would get the copper nitrate. When you have copper nitrate, is a blue color solution, because all nitrates are soluble in water, right? And when you add sodium hydroxide to copper nitrate will change to copper hydroxide. Copper hydroxide, is it soluble or insoluble? Does anyone remember from hydroxide? Is copper hydroxide soluble or insoluble? Copper hydroxide is insoluble. That's one of the exceptions. Or most of the hydroxides are insoluble unless you have the exception. So copper hydroxide insoluble, so it gives you a solid compound. How do you know a solid compound is forming? Is if you have a clear solution and it turns, by adding a reagent, it turns to a cloudy solution, that means solid is forming. Your liquid entirely is not going to change piece of rock, piece of solid, because that only happens when freezing takes place. The entire liquid would change. When solid forms and you have aqueous solutions, there would be some solution in there, some liquid in there. So don't expect everything to change to solid. As soon as you see cloudy solution, that means something has formed that was not soluble in water, and if it's not soluble in water, it's going to be labeled as precipitate or solid. You would use S designator for that compound to show that is not soluble. Like here, copper hydroxide is designated with the S label, and S means that the compound is not soluble. But copper nitrate is designated with AQ, and that means it is soluble. So these are some symbols that you have seen in experiment 7 and 8 already, but the evidence for this reaction 2, where you start with copper nitrate, you add sodium hydroxide, it changes to copper hydroxide, and that is formation of a solid. From copper hydroxide to copper oxide, you just heat up the mixture on a high heat or low heat until high temperature. Before it starts boiling, you stop, or as soon as all copper hydroxide changes to copper oxide, you stop the heat. How do you know that copper hydroxide has changed to copper oxide? Both of them are solid. So in order to identify if it has changed copper hydroxide to copper oxide, you must see a another evidence for the reaction. It's going to be through the observation. For decomposition, is going to be mostly observation, and if you can identify what would be like the most stable compound that comes out. If the compound, this is answering Jose for the decomposition reaction, like calcium carbonate, the piece that could come out of that is the piece that could come out of that is a carbon dioxide. So carbon dioxide would leave, and then you have the whatever is left is going to be calcium oxide. Like in this reaction, copper hydroxide. When copper hydroxide decomposes, the only thing that you can remove from that is water. So water would be removed. So it's a small piece like ammonia gas or something that has to be stable, has to leave. A solid or gas or liquid can leave the molecule. So it's based on, kind of it's based on observation, is based on the pattern, and based on what is available in that molecule that makes the molecule unstable, or it can leave and make the molecule stable. Like if you have N3, let's say N3 minus, that's azide ion. We know nitrogen gas is very stable. So nitrogen gas can leave. So that would consider like one of the products of decomposition. For copper hydroxide, we don't have carbon dioxide, or we don't have nitrogen gas or ammonia gas, or the only elements that are there is the hydrogen and oxygen. So you could see that water is gone. So it's based more, yes, you're right, it's more of the observation, but you could see what is the final product that you can identify. Then you would say, so if you already know, it also requires like prior knowledge. If you already know that copper hydroxide is blue color, but copper oxide is black color, then if you write copper hydroxide giving copper oxide and you balance the equation, then you could see that you can balance it with adding water. Then you say, okay, water has left the molecule. Good questions, a very good question. And that was experiment 3. Experiment 4, you are going to add sulfuric acid to copper oxide. When you add sulfuric acid to copper oxide, which is a solid compound, the state is given in the experiment reaction labeled here 1, 2, 3, 4, 5. So we know that copper oxide is solid. After you add the sulfuric acid, what type of reaction? Can you tell me what type of reaction is taking place there? Reaction 4. Is acid base? What else it can be? Double displacement. Very good. Double displacement or acid base reaction. Very good. So the product is going to be copper sulfate, which is AQ, and water, which is water. So you go from solid again to liquid, to aqueous solution rather. And because copper sulfate is soluble in water, then on the last step, what type of reaction is reaction 5? Copper sulfate plus zinc. What type of reaction? Redox reaction. And what else? How else you can identify it? There is another classification for it as well. Reaction 5 is not acid-base, no. It's a redox reaction, but redox reaction, you could have 2 or 3 different type of redox reaction. Which of the redox reactions specifically? Like if you have combustion, is redox reaction. Reaction 5, please. Single displacement reaction. Reaction 5 would be a single displacement reaction and is also a oxidation reduction reaction. Because single displacement reaction is example of oxidation reduction reactions. So your final product is going to be copper. So you start with copper and you end up with copper. You are studying the law for conservation of the mass. Mass is changing from one form to another, but is not destroyed or is not created. And ideally, if you start at 0.5, you should get 0.5 grams of copper at the end. It doesn't always happen. And can you give me what could happen that you get more than 100% recovery? So if you get 0.5 here to begin with, and after reaction 5, after you separate, you filter it, you wash it, and you dry it, you get 0.6. What happened there? What could cause that increase in mass, going from starting with 0.5, ending with 0.6? Any possible source, of course, is an error, because unless you're an alchemist, you cannot go from 0.5 copper and end up with 0.6 copper. Most likely, that's not all copper. Can you tell me what could increase that mass? Water, if it's not dry completely, it can have very good. If it's not completely dry, it can add mass to the copper. If there is any contamination, any residual contamination in the left with the copper, you don't wash it properly. Let's say in reaction 5, you don't only have copper, you have zinc sulfate as well, right? If you have zinc sulfate and you don't wash it completely, when it's in aqueous solution, you see clear solution. But when you dry it, when you heat up and evaporate the water, it would change to solid compound. Let's say you have salt water. What color is salt water? Salt and water. If you add a spoon of salt to a cup of, it's clear, no color, right? It's colorless solution. What happens if you evaporate the water or boil the salt water to dryness? What happens? Salt remains, water evaporates, because salt is not going to evaporate. And that salt that remains, there's some mass that is coming from that salt, right? It's not zero. So zinc sulfate is soluble, and it is salt, is a metal, non-metal, so it's classified as salt. When it dries up, if it's not washed before you dry it, it's going to add some mass to the copper. What about leftover zinc or leftover magnesium? You could add the magnesium or zinc. What about leftover zinc? If the zinc, you add too much zinc, and not every grain of zinc is reacted, then when you filter it, some zinc would be left over with copper, and that gives extra mass to copper. So you could have higher than 100% recovery, and if you have higher than 100% recovery, you should be able to explain what are the sources of error. Let's say you get 60% recovery. How could you lose copper? Copper did not disappear, right? You lost it in one of the steps of the reaction. Can you tell me in which step and how you can lose copper, or you don't recover all the copper? Any idea? Not enough zinc. Very good. Very good. If you don't add enough zinc, you're not going to get all the copper back. The solution would stay blue color, and you don't get all the copper back. That's one way, one error, one cause that could affect the mass of the copper, and you get lower mass for copper. What about in step 2? What could you do in step 2 or reaction 2 based on these reactions list that you don't get all the copper? See, what you have there is a copper nitrate in aqueous solution, right? Copper nitrate is in aqueous solution, and copper nitrate is aqueous solution, and the product is a copper hydroxide. What changed the copper nitrate to aqueous to solid compound in reaction 2? You have to add NaOH. Not enough NaOH to fully precipitate. Very good, very good. Hydroxide. And if you don't add enough hydroxide, I want everyone to participate. I stopped calling names because you all started answering questions, and I don't want only few of students to answer the questions and participate. So please, I expect everyone to participate, because that helps you to understand the reaction. When it comes to like mixing and just watching, I'm sure you could do that outside of the lab as well. But when especially during this time that you are not actually experiencing that mixing and hands-on and filtration, learning about the techniques, how to do the filtration, how to fold the paper, filter paper to make a funnel, to do filtration or decanting, like how to hold the 2 cups or the beakers in order to decant, that you only get the liquid portion to the other beaker, not solid. You have to make sure that solid is left in the original beaker, like techniques of decanting. So you watch it, and you learn about it in theory, but you don't do practice. So at least if you can't spend time on that, learning about the techniques, we want to emphasize more of learning about the other aspects, like being able to analyze your data. So if you don't have enough of the product, what happened, in which step you actually lost it. Okay, after step 3, if you go to the procedure after step 3, when you heat up the sample, then you have to decant this, right? You have to decant, remove the water. Because decanting is not filtration, what you do in decanting, you just you are going to pour the liquid that is over the top layer is liquid, the bottom layer, after the solid settles down, you decant. You might lose some solid in there also. We are decanting. That's another way that you can lose copper. So any way that you think you lose copper, then that means you have lost the copper, or there's any chance that you didn't recover the copper. So losing could be during filtration, during decanting, or not adding enough reagent to recover the copper. You could get less than 100% recovery. Ideally is 100. Do you always get 100%? No, you don't get 100% because there's always some experimental error that could be human error, or it could be the instrumental error. So there are some acceptable level. There's some acceptable level of the errors. Okay, and after that is just the procedure. Have to go from one step to another step. Just the particles of the blue is going to change to copper oxide, which is a black color, and then you decant. This is like how you decant. The solid remains at the bottom. You only pour the liquid without transferring any of the solid. And then you are going to, after you recover the copper, you're going to filter it. You wash the copper. And after you wash the copper, you open the filter paper under the heating lamp. You dry the copper. And after you dry the copper, you calculate the percent mass. Any questions or percent recovery? Any questions? It's a simple experiment. It's just multi-steps, but pay attention to the reactions, not just the observations, please. Okay. There is no questions. I'm going to call for attendance. You're welcome. Yes, next week. Thank you so much, Matthew, for reminding that. Next week, we are doing part B of experiment 10. So please check which part of experiment 10. And then we are doing experiment 11. We do 2 experiments. So as a result, we have 2 pre-labs. And then it would be 2 data sheets. The experiments are not long, but we have to combine them. Sorry. Next week, we are doing 2 experiments, experiment 10 plus experiment 11. The recording for experiment 9 is not showing up. So when you click on the link, it doesn't show the video. Okay, that is a trouble. Remember I said that Blackboard Collaborate is going away and we have to start with Zoom? Since I saved the videos in Blackboard Collaborate, if they probably deleted all the Blackboard Collaborate videos. Now I have to, what I have to do, I have to upload the videos to YouTube, and I will replace the link in the same folder. Instead of the link coming from Blackboard Collaborate, I will bring the link from YouTube, and then because there is the YouTube, the videos are private because they are very specific for this lab manual. I didn't make it public, so you can't find it publicly, but I will provide the link for you from the YouTube to watch the video. It's not going to be fun because I have so many different experiments and I'm responsible for entire central campus labs, but that's okay. It's my job. I have to do it. Or at least I took the responsibility. It's not my job, but for your classes, yes, it's my job. For other people's, it's not my job, but I took the responsibility. So I'm going to get and provide the link to them. For your class, I will do it today. Okay, I will do it before 11 a.m. at least for experiment 9, and then every week you will see the update. I try to do at least like 2 experiments. Thank God most of the experiments are already covered, but I will take care of that problem to make sure to check if the D2L is something wrong with D2L or is the Blackboard. And if it's the Blackboard, definitely I have to bring the YouTube videos to you. Perfect. Hannah, this is for attendance. Thank you. Sahar. Sonia, thank you. Thank you. Ashley. Leah. Caitlin? Jennifer? Greg? Jennifer is not here? Okay, expecting Jennifer to be here today. Carmen? Danielle? Davis? Caden? Siroti? Kate? Bianca? Moisha? Jada? Jose? Sierra? Javier? Lillian? Aisha? Matthew? And Ria? Okay, did I call everybody's name? Okay. Do you have any questions for me? I have to go to another computer because I don't have the videos in this one. To go to another computer, I will post the link for you. Any questions for me? Okay, perfect. Sure. No, we are not doing part A. We are doing part B of the experiment. 10 would be part B, and then 11 is part A. Or let me check before I make any mistake. I'm not changing the syllabus at this point, really. Whatever we had before, that's what we are doing. Experiment 10, part B, and then experiment 11. For experiment 11, the molar mass of unknown. We're going to, yes. Thank you, and have a nice day. You're welcome. If you have questions, please stay. If you don't have questions, have a nice day.
Hi, Professor.
Hi, Hannah. How are you?
Good, thank you. I was wondering if it's okay if I submit the lab and the pre-lab later, because right now I was checking over my stuff and I don't think some of it was correct.
Let me see if it allows you. Let me see if it does allow you. If not, I have to change the date.